Hello everyone, this is the second part of a encoders, and in this video we are going to learn how the decimal to BCD circuits can be designed. Second type of encoder, that is decimal to BCD encoder. So this is the encoder that converts decimal inputs into the equivalent BCD number. So here we have a decimal inputs from 0 to 9. So here is the truth table. So we have a decimal inputs and we have output, that is BCD output. BCD is nothing but the binary coded decimals, that is nothing but the combination of a 4 binary bits. So we have a here BCD output B3, B2, B1 and B0. So these are the outputs. Or we can say that it is nothing but the A, B, C and D. To avoid the confusion between the binary and BCD, so I have taken the output as a B, C and D. So here for decimal input 0, we have a output BCD output 0 0 0 0. For decimal input 1, we have a output 0 0 0 1. For decimal input 2, we have a BCD output 0 0 1 0. For input 3, 0 0 1 1 is the BCD output. For input 4, it is 0 1 0 0. For input 5, it is 0 1 0 1. For input 6, it is 0 1 1 0. And for 7, it is 0 1 1 1. Input 8 is written as a 0 1 0 0 and 9 as a 1 0 0 1. So this is the truth table for decimal to BCD encoder. So let's draw the block diagram. So it is the encoder or the combinational circuit with a 9 inputs. Okay, it has a 9 inputs, decimal inputs from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so these are the decimal inputs. Input, and it has a 4 outputs BCD output, that is A, B, C, D. So here A, B, C and D. So this is the decimal to BCD encoder. Now find the equations for these outputs A, B, C and D, and then after getting the equations, draw the simplified diagram. So let's have the input for or the equation for output D. So here check for which combinations the output D is 1. So here for inputs 8 and 9 it is 1. So we have taken here 8 plus 9. Then check for output C. Check the output column C where it is 1 for which input combination. So here it is 1 for 4, 5, 6 and 7. So it is 4 plus 5 plus 6 plus 7. Now check the output B. So here it is 1 for input 2, 3 and 5, 6 and 7. 2, 3, 6, 7. And now check for the A, output A. So it is 1 for 1, 3, 5, 7 and 9. 1 plus 3 plus 5 plus 7 plus 9. So here we get the equations for this outputs. Now draw the logical diagram for this decimal to BCD encoder. So we have a 9 inputs or a 10 inputs, 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. As we don't have a complements in the equations, so we have taken the single lines or the uncomplemented lines for all these inputs. Now here it is a OR operation between these inputs. So for D it is we have 8 and 9. 8 and 9. And there is a OR operation between this. So here we get output D. For C it is 4, 5, 6, 7. It is 4, 5, 6 and 7. So here we need 4 input OR gate. So here we get output C. Now for B it is 2, 3, 6, 7. It is 2, 3, 6 and 7. Again here we need 4 input OR gate and at the output we get B. Now for A it is 1, 3, 5, 7, 9. It is 1, 3, 5, 7 and 9. So for output A we require 5 input OR gate and here we get the output A. So in this way we can design a decimal to BCD encoder using OR gates.